Given the following redox reaction, identify the reducing agent, and we're given some choices in here. In no particular order, we've got the iodide ion, the chloride ion, the hydrogen ion, the chloride ion, and iodine itself. Now, with a reducing agent, we're looking for the species that is oxidized. Okay, so when I take a look at the different pieces here, the first one I examine is, I'll pick hydrogen because I find it in the equation first. Hydrogen starts off as a +1 ion, and at the end, it's still part of a compound, meaning it's likely still a +1 ion. For that reason, I'm going to not even bother checking it. I'm going to remove it from consideration. I can see next in here, I've got the iodide ion becoming iodine. Now, that is something happening. When I take iodide ion and I go to become iodine, I have to be, first of all, having a couple of these, and I have to give up 2 electrons like that. That means this species is oxidized. So that would be my likely choice, is my reducing agent would be the iodine. Now, if I look at other species that are present in here, in the first example, we have ClO3-. Now, that would have 3 times -2. The overall charge is -1, and I'm going to make X be the charge on the chloride in this case. So X minus 6 equals -1. X equals +5. At the end, I've got Cl-1. Well, that's a pretty simple at -1. So going from +5 to -1, that is a reduction. So that would not make any sense. This would be our oxidizing agent. So that one's not going to be one we're going to consider. Chloride is a product, so we're not looking at the products when determining who's the oxidizing agent and reducing agent. We're looking at the things that are in our reactant side. And for that very reason, I can also eliminate the iodine. We're asked, which is the reducing agent? So that means we have to pick something from our reactant side. So after looking at all the species that were given, iodide ion is our reducing agent.